Welcome to presentation explaining story points. This presentation has few main parts. Example to easily understand story points setup, and story points usage in everyday work. The example will focus on explaining following notions: absolute estimate and absolute time, size of a task or sum of sizes of tasks, speed of delivering work, relative estimate or relative time, or in other words, sizing. To increase ability to dive into those, please answer below questions. You can pause the video after each of them. Give yourself at most 10 seconds to answer them. Don't worry if you don't answer all of them, as the answers should be evident after this presentation. What's absolute time of a task? Does amount of actions in a task influences its delivery time? Does complexity of those actions influence delivery time? Do we need to know concrete delivery times of two tasks to see which of them takes more time? Can the same task or task of same size be done faster depending who does it? Can a team change their speed of work and so do same size ticket faster? If speed of delivering same size ticket increases and so is delivered faster, then does it mean that size of that ticket changed? If team's speed on a task increased, then does it mean that relation of size of that ticket to other tickets changed? Let's go to the example. Imagine we are a ditch construction company, so engineering company, but in a different field of engineering. And now client comes to us asking for 1 meter ditch and 100 meters ditch. Each ditch is a task. They also ask, when will you deliver them? So they are interested in absolute estimate, absolute time. If we haven't recorded lengths and delivery times of delivered ditches, like 1 meter ditch in 2 hours, then the only way to estimate absolute time for those new ditches is that engineers arrive at the dates using their intuition and expertise in ditch construction and their knowledge about our company process. That's a lot of guessing. It's better than a random pedestrian guessing, but still it's guessing. A better way is recording each ditch's length and delivery time each time we deliver one, like 1 meter ditch in 2 hours, or 75 meters ditch in 3 days. It's easy then to calculate absolute time for a new task because we have new task size and historical task sizes with their delivery times. We simply take the most similar historical task and use its delivery time. Notice ditch length is our size. In other words, length is the only component of size for now. In our case, for new orange 1 meter ditch, we compare it against our reference blue 1 meter ditch. So clearly we see we'll deliver it in 2 hours. Now for 100 meters new ditch, the closest reference task in size is the 75 meters ditch. So using that, we can say that the new 100 meter ditch will be delivered in around 3 days. Notice that if for 100 meter new ditch we took as reference the 1 meter blue ditch, we would have to multiply 2 hours 100 times, arriving at 200 hours, which is 25 business days. We would be so much off if we used the wrong reference. We just naturally uncovered a global psychological characteristic of engineering and creative work. That is, it's hard to tell how many times another task is bigger, but it is still easy to say that a task is bigger or similar. We can address that issue by using as reference tasks of various sizes. And we have that exactly here. There's one more problem to address when comparing tasks. Size has many dimensions, not just ditch length. Most popular second dimension is complexity. We'll address that in a moment, but for now, let's move to speed of delivery. I'll be using word speed and velocity interchangeably. Notice that size in time is speed. Sum of sizes of tasks in time is obviously also speed. Our speed as a company, our speed as a team can change because, for instance, after 1 year, our employees could have gained experience because after 1 year, we could have obtained better equipment. So it would be more practical to keep as a reference just ditch sizes and measure speed separately. Look at the relation of sizes with V1 speed. They are the same. Look at the relation of sizes with V2 speed. They're the same. Relation of sizes of tasks will always be the same independently of speed with which we are delivering them. And that is so useful. Imagine we could use for absolute estimation always the newest velocity to be closest to the reality. Imagine we could prove to ourselves that our new solution of some kind indeed speeds up our delivery. Okay, so now we know that in order to provide absolute estimate for a new task, we need its size in relation to some reference tasks, and we need to know our current speed. Okay, so how to calculate speed? A standard solution is to create buckets with reference tickets where each bucket has tickets of same size. Those buckets could be tier 1 tasks, tier 2 tasks, tier 3 tasks. There can be more tiers, obviously. To measure speed, we pick a fixed time unit, for instance, 1 month, and measure how much we deliver within that time unit. So, for example, in a month where we deliver 5 ditches of tier 1, 3 ditches of tier 2, and 2 ditches of tier 3, we could easily say that our velocity is 17 tier points. And we can now start saying that the new task of 100 meters is tier 2 ticket. Okay. We know size is size in relation to reference task. We know that to calculate speed, we need numbered tiers. How to include complexity in size comparison, though? To do that, we simply include in our reference tiers tasks of various combinations of ditch length and complexity. Our reference could then look like this. Tier 1 could contain 1 meter ditch with rerouting of pipes and a 7 meters ditch without rerouting pipes because they are the same size. Tier 2 could contain 20 meters ditch with rerouting pipes and a 75 meters ditch without pipes. They are more or less the same size. You might ask, how do I know that 1 meter ditch with rerouting is of same size as plain 7 meters ditch? How do I know that 20 meters ditch with rerouting is of same size as plain 75 meters ditch? How do I know a new task is same in size as the tier 2? There's a trick to tell that. It's called relative time. Let me explain it. Notice we can obtain size of new task also by comparing its undetermined delivery time to undetermined delivery times of reference tasks. Relative means you don't know exact absolute times when they're going to be delivered, but you can still tell which would take longer to deliver. It's just like when you don't need to know exactly how much time it would take you to eat an apple and eat a watermelon, to still know that eating a watermelon takes more time than eating an apple. Moreover, that relation, bigger watermelon and smaller apple, stays the same whether you're a fast eater or a slow eater. So comparing relative delivery time is a trick that gives us same result as comparing size. It tells us eventually the size of the new task in comparison to reference. But comparing relative time is way easier than comparing actual size, especially when size has many dimensions. Okay. By the way, we can rename tiers into story points, or buckets, or t-shirt sizes, or fruits, or dogs, or blobs, whatever. It's just a grouping name indicating reference sizes. We covered with the example the following notions. Absolute estimate, which is absolute time. It is a result of combining size of task with speed of delivery, or combining sum of sizes of tasks with speed of delivery. That is what clients or business usually call estimate. We also covered size of a task. It is size in relation to reference tiers. We covered relative estimate, which is relative time. And it is a technique to judge size of tasks when size has many dimensions. Now, formally, judging the size is called sizing. Informally, usually teams call it estimation, and is usually done in refinement and or in planning. We covered speed of delivering tasks, which is combined size of delivered tasks in a fixed time frame. We now understand story points, so let's set them up for our new team. We choose two sizes as our reference, one medium small and one medium big. It is efficient because with just two reference sizes, we can categorize sizes of new tasks into 5 sizes. However, it is a common practice to have as reference many sizes, and that is also okay. We can call those final sizes as we please. Story points, tiers, buckets, t-shirt sizes, blobs, anything. Okay, continuing with just two sizes as reference. We assign those reference sizes numbers from almost any arbitrary sequence. Almost. We pick two numbers from the middle of the sequence and two elements away from each other. For instance, 2 and 5 from Fibonacci sequence. It's recommended to use a number sequence that makes it slightly harder to compare how many times something is bigger, to increase chance that we mostly focus on the fact that a task is bigger. We pick already implemented tasks as reference tasks for those two reference sizes. It's good to pick tasks of various combination of complexity and amount of things to do. In the bottom right corner, there is a nice graph showing how sizes look like when containing two dimensions. There are layers where inside each are tasks of various combinations of complexity and amount of things to do. The difference between size 1 and 2 is easier to tell than between 7 and 8 if we had 7 in our sequence. It's because the bigger the new task is, the greater the error in judgment of its size. To avoid this error easily overlapping neighboring sizes, it is recommended that sizes higher in the sequence are more distant between each other than sizes lower in the sequence. That's why Fibonacci is also a nice sequence for that. And obviously, tasks picked as reference for those big sizes also need to actually be significantly different in size. We compare each new task against these two reference sizes, and that obviously means against reference tasks assigned to those reference sizes. And we assign it corresponding smaller or bigger size. When comparing size, we look at complexity of work and amount of work. The trick to do that easily is comparing relative time of new task against reference. When judging size of a task, we should include everything team needs to do: front end, back end, DevOps, quality assurance, database setup, CI/CD, whatever needed. When judging size of a task in planning poker, team members should judge size of a new ticket from perspective of a whole team, not just their own individual competencies. If that is not possible, then still, eventually, the whole team provides size for new task by discussing together arguments for that final size. Some tasks, some task types are always estimable, especially once prepared. User stories and technical chores are definitely estimable once prepared enough. Spike is making a known known, so it is not estimable. But we can at least agree on time box for it and take into sprint less story points to make space for it. If spike is estimable, then in fact, it means it is a user story or a technical chore. Bug is often not estimable because its first part is usually uncovering a known cause. But in case of a bug, we can separate investigation from fixing and estimate just the fixing. And when we have a bug to investigate in sprint, we can take less story points to make space for that. Velocity is an amount of story points done in a fixed time. So it means that sometimes we implement 3 story points faster and sometimes slower. But relation of task sizes stays the same. The orange new tasks in the top right corner will always have the same relation in size to the reference blue sizes, no matter how many of those tasks we do. Okay, even with this whole story point setup, there's still uncertainty because this is creative work. Each task is different. We are not producing identical cans of beverage, so there's no ideal reference to compare against. Ideal reference to compare against would be a task that is exactly the same thing, but that would mean doing the same thing twice, which in creative work is not valuable. It means that when measuring velocity, we should aim at maintaining our velocity with some defined variance and not at a fixed number. The variance should be defined empirically. For instance, for a team delivering on average 25 story points per sprint, we might strive for variance between 20 and 30 story points. So plus minus 5 story points, which is plus minus 20% from the average. This way we ensure that using 25 story points as speed in subsequent sprints will provide, together with sizes of new tasks, predictable absolute estimate. When many teams set their reference sets independently, then those sets and corresponding velocities are incomparable. Technically, the reference sets and velocities can be aligned by creating by all teams a common reference. So single reference set for all of them. It can be done by agreeing on common number set, picking reference tasks where some tasks are understandable only by one team and some are understandable by more than one team. And lastly, by utilizing the tasks understandable by many teams to align on task sizes. The tasks understandable only by one team can be picked to match agreed common reference sizes and be used only by that one team. Minimum reference should contain implemented tasks corresponding for at least two sizes, medium small and medium big, because that allows to categorize sizes of new tasks into 5 different sizes. And that is all. Thank you very much.